Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a look at some moons. In not the last video, but I believe the one before that, we took a look at the difference between the gas giants like Saturn and Jupiter and the ice giants like Neptune and Uranus. We are going to be looking at some of the moons that orbit these planets. In that video where we looked at the ice giants, I took a brief not a close look at the moon Triton, but I indicated the moon Triton that's orbiting around Neptune, very shiny and reflective because it's covered in ice. It's not the only one. There are several icy moons in our solar system. But what is an icy moon? Our moon has some ice on it in permanent craters at the north and south pole. The craters are pretty permanent unless another crater falls or another asteroid or comet crashes into the moon. The craters are going to last. But craters at the north and south pole of the moon, because the moon doesn't have the same obliquity or axial tilt as we do, there are craters at the north and south pole that are deep enough to always be in shadow, to always be in darkness. So they never get raised to the moon's daytime temperature. They're always in the dark and incredibly cold. So any water ice that crashes into those craters, it stays there, it stays frozen. On the other parts of the moon, if the light of the sun can hit a portion of the moon's surface, it's going to be enough to heat up the ice until it turns into vapor and escapes the moon's gravity. The moon's just too small and light to hold on to liquid water or water vapor around it. However, ice, as long as it stays frozen, that can stay on the moon's surface. Our moon doesn't really count as an icy moon. For icy moons, we're looking at things like Ganymede, Europa, Callisto, looking at moons like Enceladus orbiting around Saturn, Triton orbiting around Neptune, moons that appear to be a shell of ice. Completely, their whole surface appears to be a shell of ice. So we're looking at Ganymede here. It's not the palest of the icy moons. There's definitely some color going on here. If we move it around, we can see some areas do appear a lot paler. We can see these strange tracks on its surface. But something else that you might notice is it has a few craters, but it doesn't have those huge holes that the moon has. Ganymede seems to have enough liquid water under this ice for its surface to get refreshed. So here on Earth, we have plate tectonics, where different continental and oceanic plates can get, subsumed or slip under other plates when they crash together. And this essentially, pushes them into the mantle and they melt. Liquid material from the mantle can erupt out of volcanoes and be deposited on the surface. So over time, you get essentially an erasing of our tectonic plate. Whatever bit falls into the mantle and gets melted down, any information on that is gone. And then we can add to that here on Earth. We can add to that things like rain, wind, all of the normal erosion that we get here on Earth. With these icy moons, they don't usually seem to have an atmosphere of much significance around the actual ball of ice. So things like wind and rain working on the surface aren't going to be a factor. But what does seem to be a factor is water underneath this ice pushing its way to the surface, vaporizing or getting caught by gravity, turning back into ice or snow, as well as different bits of ice crashing together, slipping under others, essentially refreshing the surface in a similar way to how our tectonic plates, a different moon there hopped in the way of Europa, but looking at this moon here, Europa, very, very pale, very, very icy. We can see, maybe you can see some of the tracks that we can see on Europa. Europa is an icy moon, like Ganymede, a ball of ice with water inside it. Now, it is very, very likely that there is a big ball of rock in the middle. For a moon like Ganymede, it looks like about 8% is ice and water, and then you have rock in the middle. So even though all we're seeing from the outside is ice, there is solid material inside these moons. They do at least seem to have a rocky core based on what we know so far. I will take a quick closer look at Callisto here as well. You can see very similar, kind of that pale greyishy white color. We do get to see some craters, but some parts of Callisto look very, very smooth and crater-free, as we can see with this view here. So these icy moons, what we mean by icy moons when we're talking about the moons in our solar system, is a ball of rock with ice around it. And it seems like all of these moons that are balls of rock with ice around them have water in between the ice and the rock. And that's what really makes things interesting. So if we look at moons Ganymede, Europa, Callisto here, they're way out by Jupiter. They're really, really cold, or at least they should be really cold. To have liquid water in there, something must be going on. Something must be keeping the water warm enough and the melting the ice, turning it into water. It is possible that there is underlying volcanism, or in moons like Ganymede in particular, that there is, just hot rock. That ball of rock in the middle is still warm. There might still be some, maybe not liquid rock mantle, but still some very hot rocks. And there may be enough heat there to keep the ice a little bit melted. But that heat would eventually drift off into space. What we're seeing, especially with moons like Enceladus orbiting Saturn, is that they're warm enough to keep quite a lot of water liquid on the inside. But with the moon Enceladus, it's almost certainly too small to have much internal volcanism of its own. However, it's close enough to Saturn that the rock in the center, we can't even get a very close look of Enceladus here. It is very far away. But the rock in the center is getting pulled by Saturn strongly enough to keep it hot and in some parts liquid. We see this kind of tidal forces causing geothermal heating. And we see that with Jupiter's moon Io. So we'll very quickly hop back to Jupiter. There, we'll take a look at Io. We'll see how good of a view of Io this software Stellarium will give us. I think it's a pretty good view. Io should kind of look like a terrible pizza. Yeah, a little bit. So, it has these yellows and oranges, these red colors, these little black bits. It's always reminded me a bit of a pizza because it's got that kind of reddy orange of, tomato sauce and cheese. And then it has these darker regions, which could be black olives, could be pepperoni, whatever you prefer on your pizza. But really, they're volcanoes. All of these little dark areas here, they're volcanic cones. And Io is really quite small. I'll see if I can get some information over here on exactly how small it is. Most of these are about how it moves through the sky. So I don't think I'm getting its actual size anywhere here, but that's okay. It's pretty small. It's a lot smaller than our moon, and our moon is too small to have ongoing volcanic activity. What keeps Io volcanically active is essentially the tides. The same way the moon and the sun pull water around the earth, the gravity of Jupiter pulls rock inside Io. It stretches and bends and warps the planet as the moon moves around Jupiter. And these stresses generate heat, and that heat turns the rock liquid. And Io is so volcanic that its volcanoes erupting and new material melting back into its mantle, they essentially turn Io inside out every few years. Every 7 or 8 years or so, Io essentially is completely refreshed by new material melting, erupting, covering over its surface. Now, we have moved a bit into the future here, but there is Neptune, still where I would expect it to be, close to Saturn in the sky, even closer once we're into July. If we take a look at Triton in here, we'll get a pretty similar view. It looks like a pale whitish ball. I'll see how close of a look we can get. Not particularly close. Triton is bigger than Enceladus, but also significantly further away. However, it does seem to be an icy moon of some sort. Being way out by Neptune and not orbiting super close to Neptune, it may not have the geothermal heating necessary to generate a subsurface liquid ocean. It might, but it also might not. And that subsurface liquid ocean is really what we're into. The icy moons, the ice part isn't what we care about. It's the liquid water underneath. And sometimes that liquid water erupts. The vacuum of space is, a vacuum. So the pressure is incredibly low. Water inside Enceladus that manages to reach up through cracks in the ice, the low pressure of space essentially causes it to vaporize, to boil off immediately, erupting into space in cryovolcanism. It's not getting pushed out from underneath, it's getting pulled out by the vacuum of space. And that shows us that there is liquid water in there. And liquid water seems to be one of the most important ingredients for life. So the icy moons of our solar system seem to be, in the modern day, some of the best locations to look for the possibility of life. The moons that are orbiting around Jupiter, Ganymede, Europa, Those are just past the asteroid belt after Mars. Here on Earth, we have asteroids that come from Mars, or meteors that come from Mars. If something big crashes into Mars and blows off little chunks of rock, some of those chunks of rock can fall down here to the Earth. So if we ever do find that life exists on Mars, I wouldn't be surprised if we were related. Panspermia is the theory that life can spread through space, that the origins of life on Earth actually come from another planet. It could equally be applied to Mars. If there's life on Mars, that life might have gotten there thanks to a comet crashing into the Earth and sending seeded material of bacteria to the red planet. Jupiter's moons are a little further away, but not as far away as Saturn's moons. And with Jupiter, it's got an incredibly powerful magnetic field. That isn't always the best for life. Ionizing radiation, the kind of stuff coming from the sun, some of the stuff coming from the sun, can cause a lot of difficulty for the formation of life. Way out by Saturn, that little moon Enceladus, it's way less likely to have been affected by things happening in the inner solar system. So, although life that pops up in the moons around Jupiter is still unlikely to be related to us, it's even less likely if we find life in one of the moons orbiting around Saturn. It is unfortunate that right now, Jupiter and its icy moons are the target. The Jupiter Icy Moon Explorer, or JUICE, the JUICE probe, is on its way to Jupiter already, with the Europa Clipper, another probe, being launched or planned to be launched in a couple of years. So Jupiter and its icy moons, particularly Europa, they're getting a lot of attention, but just a little bit further away, moon orbiting Saturn, Enceladus, that might be an even better target in the future. And hopefully that's something we can pull off in our lifetimes. Jupiter's Icy Moon Explorer should get there around 2031, the Europa Clipper at 2030 as well. So there should be a couple of probes going around Jupiter in the next decade. When we'll get something around Enceladus is still up in the air. But if you want to get updates on these kinds of things, make sure to subscribe to my YouTube channel where I will discuss them. And if you'd like to read some of this information, you can also go to my website, greebeanscontent.ie. I hope that you enjoyed this video, and hopefully I'll see you back here for the next one.